Hi everyone, welcome to this continued video series on supervised modeling using KNN. And we are talking about the proximity-based modeling, and we are covering concepts to implementation. In this particular video, I'll be talking about how we can use KNN as regressor and what are the pluses and minuses of using KNN as a regressor. So KNN can be used as a regression option also, but mostly it is famous or popular for classification problem, mostly binary classification problem. But the architecture of KNN is such that it can be pretty useful option as a regressor as well. So let's talk about some of the pros and cons. So KNN is very adaptable and primarily known for classification, but can be utilized for regression as well. And when we talk about regression, it is a continuous target variable that we are interested in, and we are predicting the continuous variable by using a method of averaging or weighted averaging. We'll talk about both of these methods, how they differ from each other. KNN as a regression or KNN in general is very simple and very intuitive as well. The plus or the advantage of KNN as a regression is it can handle complex and nonlinear patterns as well, and that is the advantage of KNN over linear regression in some context. So the averaging method is a simple average. Let's say we have a target variable, and that's numerical, of course, because it's a regression problem. And for new data points, you're going to find k number of neighbors or nearest neighbors. And let's say the nearest neighbor, this is about housing prices probably. Let's say these are the prices 78, 85, and 95. And simple average would be just adding those values and divide by the number of samples. In the weighted average mechanism, it is about, again, the same neighbors. Let's say y1, y2, and y3. These are the three neighbors, and we're going to assign different weight to the neighbors based on their proximity to the query point or test point. So for instance, the closer the neighbors, and that might have more influence on prediction. So let's see the calculation as an example here. Let's say we're talking about three neighbors, and these are the neighbors D1, D2, D3. The distances of those neighbors 2.5, 3, and 2. So what we're going to do, or what the package is going to do, scikit-learn package is going to do, is to take the reciprocal of the distances, and that reciprocation of the number or distance actually gives the higher weightage to the samples which are or neighbors which are closer to the test point. For example, here 2 is 0.5, 3 results in 0.33, and 2.5 results in 0.4. Simple arithmetic. And we use this weights W1, W2, and we normalize the weight by sum of all the weights. And we use whatever value that you get out of this, and we multiply with y1, y2, and y3. That's how the weighted average mechanism actually works. So in the scikit-learn, we have a package called neighbors regressor. And in this, we have settings for weights, uniform, and distance. This weights, when we set it to uniform, that will be a simple average. When it is set to distance, it's going to do a weighted average. And default setting for KNN regressor is the weights equals to the distance. This is the default behavior of scikit-learn regressor module. The challenges with the regressor is pretty much the same what we saw in the classifier as well. The distance metric, so we need to make a prudent choice of the distance metric, Euclidean, Manhattan, or try with a different route for the Minkowski. That challenge pretty much remains here, and also handling of categorical variable along with numerical variable. So recommendation is to use Gauss matrix to handle both numeric and categorical variable. Let's take a look at the Python code as to how this regressor actually works. So this is an example here, KNN as a regressor. Use the regressor package, and I'm going to generate some dummy data. It's mostly nonlinear. The way we have generated is a linear relationship with a lot of noise. So you can contain the noise by removing some of these parts from the data generation. And let's say this is a neighbors package and weights is equal to distance, which anyway is a default setting, but is more readable just mentioning distance as the criteria. So you know that is going to do a reciprocal of the distances of those neighbors, 5 neighbors here. So let's do a random test point. This is a random test point and we'll make a prediction. So it will return a prediction and then we can get those neighbors of that particular test point. Let's take a look at the plot to see the data points and also the test point along with the neighbors. So this is what it is. The cross is your test point and the black dots are your neighbors, and this circle is a circle around all the 5 neighbors. Notice how powerful this is. This is a randomly scattered data, which will be very hard to build a linear regression on top of such data. So if you really have a scattered data, nonlinear pattern, quite messy and overlapping, KNN regressor can be a good option. So let's try this one more time here, and I'm going to generate a test sample randomly one more time. This is going to generate the now a new test point. Now you notice the test point is here. Now the number of neighbors. So the data pattern is very nonlinear and still KNN can perform reasonably well if the neighborhood makes a lot of sense in terms of regression. I hope this demonstration is clear. So these are my neighbors here, and I've also printed the weight and the distance. Notice the distance is 0.24, 0.25, and 0.48. The higher the distance, you will see the lower the weightage. And this is the lowest distance or smallest distance, and we have a higher weight. So the key point here is in the KNN for regression, we don't have to worry about linearity of data, not even normal distribution, not even homoscedasticity. If the data is completely random and nonlinear, KNN as a regressor can be a good choice. So that was a quick walkthrough on some of the pluses and minuses of KNN as a regressor. And thanks for watching. We'll see you in the next video.